The very first question is what's believed to be the origin of the universe, and there could be some other reasons as well, but the most accepted theory that's out there, by virtue of which uh, we can presume that what could have been the possible uh, origin of the universe. So, to answer this question, I'd like to say that the origin of universe is believed to be the Big Bang. It was an event, approximately, that took place in 13.8 billion years ago, when all matter, energy, space, and time, they all emerged from an incredibly hot and dense singularity. The next important question here is that that what are the quasars? Uh, the quasars. I mean, they happen to have some celestial objects that are found in the universe. Now, what these quasars are? These quasars are extremely bright and distant celestial objects that are thought to be powered by supermassive black holes at the center of the galaxies. And these quasars, they emit intense light and other forms of electromagnetic radiation. In certain cases, the light that's out there due to these quasars, their light outshines the light of the galaxy that's out there. Now, the next important question here is that how do these quasars form? I mean, how these quasars are born, right? Everything is born in the universe, and everything appears to have some kind of beginning. So that's what it means here. That how these quasars, which are very supermassive black holes, their source is those supermassive black holes, by virtue of which the surroundings are emitting tremendous amount of energy. Now, these quasars form when matter falls into the accretion disk, okay, around the supermassive black hole, right? So we have a black hole and accretion disk. As the material spirals inwards, it releases tremendous amount of energy in the form of light, and making quasars some of the brightest objects in the universe. So this is how these quasars are formed. Their presence is felt by virtue of the tremendous amount of energy that's coming out via the accretion disk. Now, the next important question is that what is the role these quasars play in cosmology? So these quasars serve as a valuable tool to study the early universe due to their high redshifts, indicating their great distances. Observing quasars helps researchers understand the universe's early stage and conditions shortly after the Big Bang. Right. So this Big Bang, the point is that it's a highly accepted theory right now. Maybe this theory is wrong, and maybe some other theory will come up. Now, the next important question is, what are pulsars, right? So these are some other kinds of celestial objects that have been detected. Now, these pulsars are highly magnetized neutron stars that emit regular pulses of electromagnetic radiations as they rotate. They are often observed as radio waves, and their pulses are incredibly precise, making them excellent cosmic timekeepers. I mean, precise cosmic clocks. We can say that thing as well. So these pulsars are basically uh, the neutron stars, okay, spinning at very fast rate, right? Now, how do pulsars form? Now, what are the bases that these pulsars are formed, right? So this can be another question that can arise in our minds. So how these pulsars are formed, and what could be the possible reasons for these pulsars to be there, which are basically the neutron stars. Now these pulsars are formed from the residues or the remnants of the massive stars that have undergone supernova explosion, and the core of the star collapses. It collapses under its own gravity and forming a neutron star. Now, if this neutron star has strong magnetic field and is rotating, it can become a pulsar. Now, what's believed to be most important thing here is that in pulsars, when the star collapses, there is formation of protons and electrons. So these protons and electrons neutralize and give birth to the neutrons. That's why these pulsars are basically neutron stars spinning very fast on their axes. Now, the next important question is, why do pulsars emit pulses of radiation? This is another important question, that why? What could be the possible reasons that they are emitting the pulses or the radiation pulses? And these pulses are transmitting, they are traveling very large distances in the space. And what could be the possible reasons for this kind of question? Now these pulsars, they emit pulses of radiation due to their rapid rotation, okay, and misaligned magnetic fields. Now magnetic fields are misaligned. As these fields sweep across the space, they create beams of radiation that are detectable as regular pulses. And when they point towards the earth, the disturbances they cause, these disturbances are detected. These disturbances are detected, and the presence of a pulsar is felt through the sensors. The next important question is, what are the applications of pulsars? I mean, what could be their possible applications for the sake of study, for the sake of understanding the universe, for the sake of learning that how accurately we can demonstrate the universe at its beginning, because we know very less about the moments after the Big Bang. So these pulsars can be the signatures, and they can certainly have these kind of capabilities. These pulsars are used in various scientific applications, such as testing the theory of gravity, right? Detecting gravitational waves, and even potentially serving as navigational beacons for interstellar travel due to their precise timings. So these could be some of the important possible applications of studying these these beautiful celestial objects, which are known as pulsars. Now, from life point of view, from stimuli point of view, from no point of view, whatever is there, that's very painful for us. I mean, but studying these things is always a passion, and we can have more understanding of the universe. Now, the next question is that how are pulsars related to the neutron stars? I think I have already tried to answer this question by extrapolating that if you have a super massive star and there is a supernova, if the star blasts out and its core collapses. Now, under certain circumstances, depending on the mass of the star, there is the presence of electrons and protons. And these electrons and protons, they neutralize and they give birth to the neutron star. So here I should say the neutron stars are incredibly dense, massive stars. I mean, and pulsars are a subset of neutron stars with strong magnetic field and rapid rotation.